Hello and welcome back to Higher Maths Functions and Graphs extension to logarithmic and exponential functions. So in the previous video we looked at 1a, 1b and 2a, which I would say are reasonably routine questions. So a separate video for 2b and question 3. So state the domain of the following functions: h of x equals log to the base 3 of 2x plus 5 minus 3. Again, treat this as a transformation of graphs question. So remember, just like with the trigonometric graphs, we need to take out a common factor here. We need to take out a common factor of 2. So that'd be log to the base 3 of 2 bracket x plus 5 over 2. So this will compress the log graph. So here's the log graph over here. This will compress it by a factor of 2 towards the y-axis. So rather than crossing at 1, it would now cross at 1/2. But again, it still would not touch the y-axis, squashing it towards the y-axis. And the x plus 5 over 2 would move every point on the graph 5 over 2 to the left. So at the moment, the y-axis is an asymptote, is a straight line that the curve gets very, very close to but doesn't reach. So if we move all of the points 5 over 2 to the left, then rather than x having to be greater than 0, x would have to be greater than negative 5 over 2. Okay, it could take any value of x larger than negative 5 over 2. And then minus 3 would just move the y-coordinates everywhere on the curve down. But it does not change what the x-coordinates can be. It's just literally just shifting the graph down by 3. The x-coordinates would not move. So the domain x is an element of R, but x must be greater than negative 5 over 2. Again, that is because we are shifting 5 over 2 to the left. Right, question number 3. I think this is just such a beautiful question. So f of g of x, express f of g of x in the form a 4 to the x, where a is a constant. So f of g, so we know what g of x is, so f of x plus 2. So we'd get a mark for doing that. And then finding out f of x plus 2, so just wherever there is an x, we replace it with what's in the bracket. So that would be 4 to the power x plus 2. So we're having a look at that, and we're thinking, well, hang on, this is saying a bracket 4 to the x. But remember, our rules from National 5, a to the m plus n is a to the m multiplied by a to the n. So I can write that as 4 to the x multiplied by 4 squared. Well, 4 squared 16. So I have 4 to the x multiplied by 16. And I can write that as a times 4 to the x just by putting the 16 at the front. So it's 16 bracket 4 to the power x.